Each of you want to introduce yourself and what you work on?
Hi, I'm Davey. I'm working on a project called Poetic Technologies. New team, we're trying to apply cryptography distributed systems ideas to old ideas of credit theory and money. Basically working on credit clearing and mutual credit protocols. Also our domain and focus is all on supply chain security, or social supply chain security. Large overarching goal, I would say global debt cancellation and redistribution of everything.
I'm Andrew. I work on smart contracts and privacy technologies, and especially in my trusted hardware era. And so most of what I'm really interested to talk about what trusted hardware can do in terms of information flow control. I think it changes a lot of what people's expectations, if they have any, are about what can be done with IFC. So, yeah.
Hey, my name is Henry. I'm the founder of Penumbra. It's a shielded DEX app chain, so you can transfer funds in, and then there's a DEX that you can do trading with. So the idea is like trying to find one specific use case that you can use to exercise all of the end-to-end protocol flows for a protocol that is both useful and has some notion of information control.
I'm Christopher. I work on Anonymous. I may or may not be partially responsible for this panel, but I have no idea because we lost control of that information. But recently, we've been reading a bunch of distributed systems literature because we're lazy and don't like reinventing stuff, and came across this concept of information flow control, which of course doesn't mean one thing, it means like 5 related things. But it does seem useful for what we're trying to do in distributed systems, especially those which handle intents using cryptography. So that's why I'm here, I think.
All right. So the first kind of question that I want each of you to kind of think a little bit about is, the goal of a lot of privacy-preserving technologies for restricting information in kind of blockchain settings are so that when you have an adversarial attack, it's much easier to reason about the strategy space of the adversary. You've restricted the strategy space; they can't do as much, or they kind of have some bound on like how much they can do given the compute budget. So, a kind of classic example of this is go into Reth or Geth, look at the consensus node slashing rules, and count the number of branches using. A lot of those branches are because slashing events have to have a ton of censorship-resistant properties, right? Like someone could try to censor a slashing event to themselves if they're the composer. And so there's all this like really ugly as fuck logic that goes into slashing events. On the other hand, if you did the slashing event at TE, you only need a one-event trust assumption because anyone who would get some incentive for executing the slash doesn't know who the slash is for. And so as long as one person's willing to execute it, it's easy. So your slashing rule code might go from 10,000 lines of code to 50. So in a lot of ways, that's sort of this is just my interpretation of what information control, flow control is supposed to be about. So in the things you're working on, where does that come up? Where are things where you're using cryptography to actually simplify implementations because you suddenly made the adversarial threat model a lot more easy to reason about? I don't know who wants to start. Maybe Henry.
Sorry, I was brainstorming. I feel like it's like a little off panel, but to me the example that most comes to mind with that description is not even about the software systems, but the distinction between like a conventional multisig and like a threshold MPC signing thing. If you are disclosing the information about like what is the T of N and exactly which wallets are the signers on a multisig, that's like a much worse position to be in than if you're using some cryptography to like hide all of that, do it off chain, and just like produce a signature that looks like any other signature.
And you use it.
Oh yeah, that's how the custody for Penumbra works. It's like threshold signing.
Yeah, I mean, it's also not exactly the question you asked, but it's related. to me, part of the advantage of thinking about things through the lens of information flow control is to allow you to reason about sort of game theory and the strategy space at the right level of abstraction, like at the level of abstraction of which agents have which information, instead of doing something that's very dependent on specific cryptography primitives. So like maybe you could, craft an incentive model or a strategy model based on certain information flow control assumptions and implement that with TEs now, and open yourself up the option to implement it with something else in the future with like certain different cryptographic assumptions, but not needing to change your model.
Can I take a step back and can we all define information flow control and what it means to us in our specific cases?
Chris goes first. I have been trying to use the word in a way that is sort of concordant with the academic research discourse, which mostly comes from distributed systems. In particular, there's a paper called Viaduct from Cornell from about a decade back or something that is working on distributed information flow control. Now they do it in the kind of one-shot compiler approach. So you write a program, and the program describes different agents and what kind of trust assumptions you're willing to make with those agents, what information you're willing to reveal to those agents. And then the Viaduct compiler takes that program and selects specific cryptography primitives to implement it, which preserve those information flow control properties. Like it can select zero knowledge proofs or just simple signatures, hash functions, public key encryption, even select KBC. Now they do it in this kind of one-shot compilation model, which doesn't really fit quite. It doesn't quite fit the scenario we're operating in. The scenario we're operating in is much more like many people are writing many programs, like the whole state of the system is constantly changing, and you want, both maybe as a program or as an application, and also as a user, to be able to reason about what information will or won't be revealed to whom as a result of your actions. And as a developer, you want to be able to write programs at a level of abstraction where you're talking about what information flow control properties you want, what you want to disclose to whom, and then can use the compiler to spit out or at least pick the right cryptography.
Is it similar at all to like selective disclosure?
Probably yes.
Because the way you just described that, it sounded slightly similar.
There's specific, theoretical frameworks, for example, that allow you to reason about information flow control through a program, and Viaduct allow you to select specific cryptographic primitives which preserve certain integrity information flow control properties. So I don't know, if that relates to selective disclosure, but intuitively I would say yes.
What does it mean to you, Andrew?
Pass. I do think that there are many notions of information flow control. The one, I'll give my version that mostly matches what Chris is talking about. So I think of this as a kind of formal methods. It is a way of indicating something that you want to your program so that your compiler can reject your program if you make a mistake by not doing it right. So one example, I'll try to walk through kind of the basic example of information flow control. I think I will get it right, but these are like the academic notion and kind of a simplified example. You often just say you have two labels, like high security, you don't want to leak that, low security, that's a public variable. You might have an access control structure in your code that says, well, anyone can read the low security variable, it's public. No one can read the high security variable, it's not. There's a kind of error you can make when you're writing your program and you put a bug in your program because you're not good at coding, and that's you can take the value of the high security variable and write it into the public variable, and now when someone goes to read the public variable, they're learning the contents of the secure variable that they shouldn't, even though they weren't supposed to, and that was the intent. Now, there wasn't, how do you prevent against that? You just don't do that, right? That was a bug, and you should know better than to make that mistake. And hopefully your auditors, if you're basically doing the equivalent of this in a Schmitt contract or something, then hopefully your auditors catch it. And what information flow control, and this is in basics of, the Viaduct paper was like the most recent and most powerful version of this from Andrew Meyer's group at Cornell. But they did earlier versions of this through multiple decades prior. So that newest one kind of automatically enforces this for your MPC program. It helps you tell if you're about to make a wrong program because you wrote the wrong thing, because you labeled those variables that way, and it can detect that you've made this mistake and reject it at the compiler level. you don't necessarily need fancy technology to do that. It's like a way of, avoiding a mistake that you could have avoided if you knew to think about it, but the logic helps structure how you would think about it, and it leads to a compiler that can avoid this class of mistakes for you.
Well, I'm not a third source on my opinion of research on this topic. Like I can say maybe not. I cannot explain what it is, but I can explain why I'm like interested in this direction. Maybe I feel that first of all, information flow control sounds a bit like top down. It feels like it can be it can lead to good things, it can lead to bad things. But like why I am personally interested in this like direction is I feel it's a direction of design that can allow people to like horizontally organize and create systems where you can dictate rules. And this is the main thing that I'm interested in, I would say. And yeah, like I can give like an incredible example of how I think about last year I read the book called Circe about Circe about the nymph and the witch. She was talking about, there was a mention of this Greek concept of pharmakia or pharmaka, which is like a plant with magical powers that even gods cannot sort of reverse the effects of. And I feel like cryptography and like this kind of tools that can sort of play the role where you can dictate rules in a way if you able. But the thing is that you have to first organize your output somehow, and this is like the most complex thing. So I don't know. Yeah.
So Tina also made it clear that she didn't really want it to only be about the cryptographic methods or like the sort of formal work, but also somehow talk about DeFi and confidential DeFi, which is probably why I guess she asked us to do this. So if I think about confidential DeFi, generally there's sort of three classes of state that you want to have, right? You have fully public state, which is I'm showing a user a price. No one is going to use your protocol if there's no public state whatsoever. And I caveat that with meme coins don't count as protocols in this definition. But no one is going to like send money to an address and expect something to happen without some notion of public state. Then you have fully private state, right? That's the idea of like, I'm a searcher right now, I keep all of my current positions on Binance completely private relative to the blockchain. No one knows that. No one knows I'm hedging some particular position. No one knows my sex side position on the sex side. Then I have semi-private. And so semi-private is when you're taking aggregations across many people's private data or many people's, or public and fully private data. And you are adding some noise to it. You are sort of kind of transforming it so that you can post the aggregated data, but it's hard to understand it's hard to identify individuals with high probability. So I would call that sort of like statistically private state. In DeFi, you have to think about building all three of these, right? You have to think about where these revelations happen. As you're writing code, you have to think about, okay, to Andrew's point of like, hey, is this variable, what's its lifetime? Is its lifetime going to be as perpetually private? Is its lifetime going to be statistically private? And when you transform between those boundary domains, obviously you have a lot of properties. So in the protocols you're working on, how do you think about this partitioning and how you think about partitioning state versus execution, how you keep them separate? Obviously I think T's versus ANOMA are two very extreme, you're going to get different answers for how the state is partitioned, so that's what I'm curious.
The numbers are in between.
Yeah, well, you guys sound in the right order, so not my choice.
Henry goes first.
Right. So branching off of the previous prompt or whatever, one case that, as an example of like flow control that makes things easier to reason about is for Penumbra, the model we have is that all of the per user data is in the shielded pool, and that's private, and all of the chain state is public and transparent. So all the positions on the DEX are public and known to everyone. That's like obviously a lot easier to implement. But when someone creates one of these positions, the order that they make is funded out of the shielded pool, and it's not updatable, so they have to close it out and put those funds back into the shielded pool, and that makes the reasoning about it a lot simpler because there's no long-term linkage of I see this position was created at this time, and I can immediately infer that this is part of this person's complex, like multi-leg strategy. I just see someone has created this position. And that is substantially easier to reason about because you're just seeing the individual pieces. The second thought that I think is interesting is I personally am like quite bearish on pretty much any kind of protocol that requires user interaction. And for this reason, I think that a split between private per user state and some public state that they can interact with is basically the like middle ground that you have unless you are like going using TEs. Because anytime you have a system where users have to interact with each other directly, like I have to do an MPC with you in order to do a trade, now from the sort of system developer perspective, it's very, very challenging to get any kind of adoption for the system because you have to onboard users in pairs in very, very tight time. Whereas if people are interacting in some public way with some public state, that on-chain state can basically act to smooth out the user onboarding over time. This is why I think like Uniswap worked really, really well, and atomic swaps were like the nerd thing for years that no one ever used. It's because in that case you get to interact with the contract, and so as an individual person you can just choose to opt into doing it. Whereas if you have a cryptographic mechanism that requires you to be interacting with another party, now you can't just use the coordination technology to do stuff. You first have to like pre-coordinate to find the person that you're going to interact with.
So, yeah, I want to go straight to how MPCs, this could be true of the number
Oh,
of
you wanna?
Do I have to go louder?
Okay. Alright, still time.
I want to reject your framing a little bit of, I do think that there's another kind of information categories. You went through public, private, and semi-private, which you described as leaking some information maybe in an aggregate sense about these. What I think we really have the opportunity to do, and I really want to draw attention to this, so it's tricky to categorize things beyond that, but I think we can. I care a lot about like the auction setting and the notion of failed bid privacy. So one of the things I most am concerned about is if you contribute your bids into an auction, and it's the kind of auction where your bid can fail if it's not the winner of the auction. I really want to make sure that your failed bids are hidden. The reason being that that's a good predictor of your unmet demand that reveals kind of what you're going to trade later on. So failed bid privacy is really important. But then that notion is a little bit different because there's a chance, depending if you won the auction, it would be revealed. But if you didn't win the auction, then you revealed no information, not even in aggregate about it. And this is certainly something you can express with an MPC auction. I think this is true of Z-Swap, except that I don't think you really have a notion of failed bids because you get whatever your amount was traded at that price without it's not like you have a slippage limit.
Well, what we ended up settling on actually is a mode where we don't attempt, at least in like the V1 of Penumbra, we just kind of like axed the whole let's threshold encrypt all the stuff and do the encrypted batching because it was not really clear to us that the marginal increase in like product value going from I can do a transparent interaction with a public position to I'm going to be private within my batch, but maybe the batch size is 1 because it's like a new protocol that nobody's using. And shipping things is hard.
Okay, but it makes sense your reason for choosing that, but it's something you could do under the same threat model regardless of that to provide that failed bids privacy. But to me, the right way to think about it's hard to pick like what's a good name for another class of things that this falls into. It could be conditionally private maybe. But I think the really key shift is that we normally think of access control as who can see what, you're kind of limited to that, and if you give someone information, you can't control what they do with it afterwards. You can have a contract, you can try to slash them if you determine that they've conclusively leaked something, but that's really hard to do. But with MPC and trusted hardware, you can not worry about who you're giving the information to, but how the information can be used. You can give information to a program, not to a specific set of people. And that seems to open up a whole lot else. So I think that's needs more categorization.
Yeah, that's fair. I was just trying to figure out that simple, not have like 10 categories.
Yes, well, I'm afraid that at least I'm going to play the bearer of bad news, because I think we have infinity categories. And I would add two
Sounds like such a
dimensions.
bad joke.
I would add 2 dimensions to your categorical scheme, which are identity and time. The first one is one we care about, particularly related to this problem of counterparty discovery, because we also want to support some kind of non-interactive party discovery where users don't have to like find each other in a sketchy bar in Brussels in order to trade. And in the context of supporting that, we think a lot about to whom specific intents are sent. Because in, at least in the Enoma way of thinking about things, you have kind of 2 phases of counterparty discovery, where you're trying to discover a mic that works at settlement, where you're trying to post your transaction somewhere. And privacy and settlement is much easier, because once you know what the transaction is, you can just make a zero knowledge proof about it, at least for all the parts of the state changes that are known. Whereas privacy and counterparty discovery faces the fundamental trade-off of, in order to discover the counterparties, you must reveal some information about what it is that you want. So we care in part about reasoning about to whom users are revealing that information, how long if these users say they're supposed to store it.
Alright, now it's time for a celebrity guest question. Oh, this is weird. And in that Hart thinks a lot about these types of solvers and getting them to show up to his protocol and make sure their users actually get their funds across. No pun intended. And how do you think about this kind of counterparty discovery in a private world? You had to rebuild your protocol assuming you had information flow control.
Okay, so you guys like panel of super smart big brain cryptographers. From a finance perspective, what do you care about? You care about no one arbitraging or screwing over your users. So you want to have the user reveal the minimum information about what they're trying to do in a way that gets them the best fill possible. Right?
So how do you figure out like the value to the end user of using all these flow controls? Like how can they price them? And Henry probably also does.
No, I have a question, which is, what happens?
I'm not on the panel, dude.
Yeah, you're just doing the whole like, okay, let me tell you the alternate perspective. So here's the question from that perspective is, what happens for a user when those 2 goals that you mentioned are actually in tension, right? Like, if I am revealing the least amount of information possible, does that actually get me the best fill? Or if I reveal some information that says like, I am a random MetaMask user and not Citadel, like maybe that gets me, better pricing.
Yeah, I mean, I agree with that, right? So it's like you can discriminate order flow to give uninformed retail flow better pricing than informed flow. That's something that happens. Generally speaking, and my mic feels really loud here, but generally speaking, my take would be you want to use competition in like a cross-chain bridge. Generally, I want to give the user the most funds possible on a destination chain. And if you're trying to do this in a private sense, this is not something I've thought a ton about because this isn't my world, but you want to give, you use an auction or some form of an auction to figure out who's going to pay the most. And I think then where I think the information flow control stuff gets really interesting is running that auction in a verifiable and maybe private way, like our friend Andrew here can build, and you can get pretty cool effects that way. But I don't know if that's answering your question, Chitra.
No, that's good. I just needed some
Spice.
third party spice.
Markus, you got anything to add?
Sure. I think adding to what Hart said, it's important to realize from a practical sense that today most auctions are publishing most information. And that's like the default that we have, which is easy, but also a bit naive. And I think we will most likely see changes being made to these public auctions as we see and are more aware of the costs that users are paying for having their information revealed. Like today, I don't think it's a stable equilibrium with having absolutely all information of intents, especially on larger swaps, on public APIs, and rather we have to find ways to make that information private somewhere along that scale of gray. To not have users be front run.
Yeah, blue. Okay.
Yeah, I just wanted to note my other dimension, but it's related to this question, I think, is to me at least information flow control is not just about whether state is private or not. It's also about when people can verify certain things. So credit actually for this idea to Vitalik, who mentioned it on another panel we had about information flow control, which I know is a meme. But for example, you could create a proof of something like either I know state such that X, like I know a piece of private state that I'm willing to swap for another piece of private state, or I know the output of a BDF function, which I couldn't compute before a certain time. And now you've created a piece of data, a proof, that before a certain time in the network, it provides like proof of something that's relevant to a state transition, right? It could be part of an intent, could be input for a swap. But after a certain amount of time, it actually proves nothing because someone else could have made that proof just knowing the BDF output. So I think there's this like interesting temporal dimension that would often play into actual financial market structures. It could be something to consider.
Yeah, absolutely. I think pre-trade privacy is much more important than post-trade privacy.
Cool. I know we're almost running out of time, so I'm just gonna kind of go have you guys answer one final question, which is what DeFi application do you think will use information flow control in practice and production with at least $100 million of assets? First, what type of purpose?
Should they name names?
What
does it exist today?
It might not be one that exists today. It might be something, but you have to be able to describe it. You can't just say not everything that exists. You know, it's kind of boring. That's like being like the guy in Times Square with the like Jesus is coming place.
Yeah, I'm gonna be this guy. But in my
We gotta get your cardboard box.
I don't care about DeFi really. For me, it's it's casino. Like you just casino with traits of subculture. I mean, I see it like this, but like you mean you play within you play within the system to get more chips to get them out of the system, and then you pay for stuff. Like this is the only thing that DeFi can do right now. Like yes, and so for me, like I care about like how do we make tools for. I mean, in terms of DeFi, actually, you cannot at the same time you cannot ignore it. So it did like provided some background like what's called like playground to explore some concepts like economics in economic field and like in distributed systems. So like it led to some good outcomes in terms of like it provided some like it provided like playground to explore cryptography, distributed systems, economics and stuff like that. But at the same time, I feel like I don't like try not to glorify it, like I don't take it seriously. Like one thing is hard for me to think about is how do you like bootstrap real economies, and so maybe DeFi can be used as a tool to do that. So in the sense like you have like order like the thing that I discussed recently with my friends is like you have order books, dexes, and you can use them to provide liquidity to like grassroots economics, where you can have like liquidity that clears the debt within a closed community that actually tied to real stuff.
We have to end soon, so we gotta.
But then you can switch the tracks and you reverse it. So like if you're able to combine enough pool of people, like able to bootstrap a big enough community to actually have enough computational power to then dictate rules to Dexes, then they would just like their order books go like shallower and shallower, they would shut down.
Okay.
Yeah.
Thanks. we gotta move on. But actually, I will
My
say.
short answer is penumbra.
Yeah, I know your answer. that's
Let's go.
I think I'm pretty excited about the mutual credit kind of direction. I think that in the near-ish future, we will see a lot of different economic behavior among people that looks a lot like lending money to family and friends, but it won't be in the way that you're used to, which is kind of unhealthy and bad because you won't have to know when the friends who you've offered credit lines to have taken you up on it. So you'll have a friendship bankruptcy protection mode of lending to friends and family that is protected through information flow control. So better pure economics through information protection.
Yeah, well, I kind of agree with that answer, but to try and come up with something else that's different and interesting, I would say maybe we would have some kind of private or large-scale public goods funding using information flow control. It's through certain data to certain parties at different times can just create different incentives for people to like when you want to issue certain evaluations in a way that you don't want other parties to always see who's saying what. I think this can be pretty helpful. You can create lots of interesting structures for surfacing honest preference information. When people know that the preferences that they're providing to the system aren't necessarily going to be used against them in coercive scenarios.
All right. Well, hey, give a round of applause for our panelists. I hope we've either learned a lot about information flow control, or we've done such a good job at conveying that we know the concept without revealing anything. It was so confusing to understand that, it worked.